Could they also do what some of our portfolio companies do? Answer that I gave was no. When you're talking about the kind of companies that we are investing in, their proprietary data is illegal to be made public. If you have four of us sitting here and we all have different chronic diseases, our DNA, our blood work, our prescription medicine history, those are proprietary data.
And now they have a solution where pretty much most of the protein folding is solved. The agentic AI is still going to be there. It will just start taking advantage of the world model now. Eventually, we may be able to get to AGI. It doesn't really look at the world as an environment in which we live in, where everything is changing.
I want to make sure that I don't waste their time with bad deals or bad companies. So when we go through that, once we meet with them, then we get a better feel for who they are. Then we can do a little deeper dive into them. We look at the team, we look at how much revenue they're looking to make with the funding versus what they've been on track before. And then we look at how the market might change in the future.
So, episode 2, we are here with the Quartus Capital Partners team, diving into the AI playbook, AI Value Playbook that we have and that constantly evolving. And we have Al, Rizwan, and Barry in the conversation, and we want to dive deep into, why don't we go into the AI playbook that we have in Quartus? Why don't we unpack it? Can we cover the layers that we have?
Well, I think first thing to talk about is why we needed to have a playbook.
Exactly.
Right. And main reason is that the frameworks are always made. We have made the frameworks in the past whenever the new technology came in, but those technologies were not changing as fast. AI is actually changing extremely fast. Mm-hmm. And so we ended up actually, to understand for our own sake, we ended up creating a framework, right? So that we can see what are the different layers, what is happening, which company is playing what part in this entire AI scheme and game. That's why we created the playbook.
So Rizwan, you created in terms of with the team, what's your AI Quartus Capital Value Playbook. And it has interesting way of moving around and incorporating what's happening new. When we first unpack the model, and then we can go later and see how it has evolved since inception.
Sure, yeah. So we obviously we created that framework for ourselves to kind of understand where we want to invest in. We needed to understand the different sectors, layers of the AI. Mm-hmm. And we looked at it and we said, okay, we got to actually bring in a spatial division as well as a temporal division, which means that what are the different sections and segments of the AI, as well as how it is progressing from the time point of view, right? What is happening today, what will happen in a couple of years, and what will happen in the future. So that's the idea behind the framework which we created. So we have 6 layers of our framework which we created. The bottom layer obviously is the infrastructure layer. This is where AMD, NVIDIA, Intels of the world, and all the networking companies, Cisco and so on, they actually fall over there. And then the layer above top, which is actually the customer of the bottom layer, which is the middle horizontal layer. That horizontal layer is the cloud layer. This is where Google, Meta, and so on, Amazon, which actually have the cloud. So AIization of the cloud was happening because everybody was actually implementing GPUs. And of course, Google has their own TPUs. So that is the layer which is being prepared for the AI infrastructure. Mm-hmm. And above that is the model layer. And the model layer is the customer for the middle layer. So this is how we basically start thinking about it.
Companies in that layer?
The companies, this is all the model companies. OpenAI is there, Anthropic is there, right? Even Google themselves. This is where all the innovation and the model and around model is happening. For example, not just LLMs, there is a reasoning models which are being created over there. All other software like vector databases will live over there. And then on top of that is where the applications live. Now we wanted to understand in application layer where we can invest, where we shouldn't be investing. So we sliced and diced that top layer into 3 vertical layers. One is a generic wrapper applications layer. And then the middle one is more of a high impact AI areas, very specific industry specific areas like healthcare, fintech. So that falls in any applications built in that particular sector falls in the middle layer. And then the last layer is something which is very interesting for us, but we right now don't want to invest in that, which is the physical AI layer or embedded AI layer, if you want to call it that. So in that layer, all the robots, even we consider Tesla car as one of the robots, initial robots, and eventually Tesla is going to bring in Optimus, the social robot as well.
The one that does the dishes. I like that one.
Right. And yes, everybody would like that.
The one that does the dishes. I saw that one. Right. I like that one.
But then there's a whole industry 4.0, where everybody talks about with the IoT. Mm-hmm. But then the next phase, I'm kind of calling it 5.0, if you will. So that whole AI, which will go into the industrial robots and in industry in general, that is the last application layer which we have. So from our perspective, we wanted to focus on the middle vertical layer, which is the high impact.
Why so?
Because of that layer is where you have expertise in a particular field. Mm-hmm. If you talk about medical field or healthcare field, whether it's neurology or any other specialization, people who live in that space, they know what exactly is happening over there, what are the processes over there. They have their own data, which is proprietary data in that particular space. That is what provides the moat. And even in terms of building an application for our healthcare provider or anybody else in that space, those are the people who actually understand how that whole workflow should be built. So that's the moat which will be there, because LLMs and any kind of models, that itself is not a moat for anybody anymore, because there's so many people who are building that thing. And tomorrow, there is going to be further innovation in that space, and there could be a completely, entirely above and beyond LLM models coming. So it could completely actually change the game. But the application remains the same. Those ideas remain the same. You can just replace with the new model, right? So that's where the maximum moat protection is. That's why.
Where's the most crowded space of investment right now in terms of the model that we have?
Well, the most of the money is going into the the model layer. That's where OpenAI is getting a ton of money. Anthropic is getting the money. There is so many new companies. The people who actually worked in these companies, they left. They are being given billions of dollars. We're not talking millions. Right? Anybody who leaves, especially who is a well-known person, is getting $1 billion easily with $10 billion valuation, without even having a single line of code.
So question was crowded market, not where the most capital.
So crowded, of course, is the vertical first layer, which we mentioned, right? Mm-hmm. So that's where everybody is building wrappers. Anybody and their grandmother has an idea, right? And they immediately can put something together, because most of the work is really done by the LLM layer.
And what does Quartus Capital bring to the portfolio companies and the second layer, vertical layer?
So, I mean, that's the area where, we, work very closely with the companies. We want to make sure that they understand what the moat they have. We want to protect that moat and help them actually navigate as the things are changing underneath. Constantly be communicating with them, telling them that this is happening in the industry. You need to pay attention to that. So that their moat is protected, because that's our biggest fear in this space.
In a nutshell, we help portfolio companies in the second vertical layer to solidify their moat. solidify, strengthen their moat by updating their technology stack, by staying ahead of the onslaught of new innovations that are happening.
So, for example, one concept which we talk to those companies is just from experience looking at some of the successful companies. You look at Google, for example. You look at Meta. Why they were so successful? They were successful because they were capturing all the data. They were keeping it to themselves. They were leveraging that data to provide more innovative solutions.
Right.
And this whole process where you have a complete loop of data being fed into providing the services. And as you provide the services, you capture more data, you bring that data back. So that idea, we talk to these companies all the time that the data is the key, data is the currency, data is gold. So you need to pay attention to your applications to be able to, even if it's anonymized data, doesn't matter, right? You don't need to keep non-anonymized data, but you need to capture that data and use that data to further your goal. So that's one thing which we discussed with all of our portfolio companies.
In terms of what shifts have you seen in terms of a playbook? Do companies go from one stage, one layer to the next?
Well, I mean, from the playbook point of view, we are talking about 6 different layers, and there's innovation happening in all. So this is one thing very different. That's why, also why we needed this playbook, because in the past, you never saw this much innovation happening in each and every layer of the framework.
Right.
I mean, if a new concept, new technology came in, the bottom layers were pretty consistent, constant. Application, of course, was constantly shifting and changing, but your framework pretty much stayed the same. But now you have at the chip level innovation going on.
Right.
You look at NVIDIA in the past 4 or 5 years, from A100 to Hopper 100, H100 to H200, and now Blackwell. I mean, it's essentially so much innovation which has happened in terms of bringing the cost down, bringing the power consumption down, and the high efficiency chips, that it is impacting all the layers above. So much so that the business models are being changed. You look at the cloud companies who are actually leveraging these chips. They are certainly within like 1 year or 2 years, they're ready to rip the old GPUs out and put the new GPU in, which essentially means that what is the lifespan of those systems and computers, which used to be 5 years plus? It is less than 2 years now, right?
Right.
So they are completely, rethinking how their business model should work. Similarly, the models up there, which actually, one of the things which was a concern 5 years ago, 2020, if you remember, people were saying, "Oh, it's extremely expensive. For 1,000 tokens, you need $1. Right. For $1, you can only buy 1,000 tokens." And people were questioning the fact that in order to provide a proper use of it or applications, it's going to be extremely expensive. What is the cost right now? It is a fraction of a cent for 1,000 tokens. Right. So it's completely changed, how people were thinking. Nobody is talking about cost anymore, right? People are then start talking about, do I have enough GPUs, right? And so that was happening like a couple of years ago. And then eventually your bottleneck became power. So that's why, remember, we used to talk about petaflops. I have a data center, which is petaflop data center, right? What are we talking about right now? Gigawatts, not flops, gigawatts, right? So I have a data center which is this much gigawatt because power is the bottleneck, right? So that is, what is going on, in general in this space.
But circling back to your portfolio companies and what Quartus Capital has and that second vertical space, things that have challenged them the most, and in terms of, this is forever changing, and we can say even faster than any time in space. How do you keep them up to speed, or that's the, like we call it, our blue zone that we want to invest in.
Right.
we should call it purple zone,
Right.
that we want to invest in. How do they keep in shape into that space since these are moving parts?
Right. So that's what we talked about, that why we invest in middle vertical layer, because there they have their own proprietary data, where they have their own moat in terms of understanding of that particular space. That is protected. That is intact. That doesn't change what is happening.
Regardless of the new chip.
Right. So only thing what happens is that as the new chips come in, as the model become more intelligent and more efficient, they just take advantage of that. They just take benefit of that, right?
But it might challenge. I mean, the threats that a vertical in the financial sector or in the healthcare sector in one particular, say, heart problems, that, I mean, these models that are happening in terms of Anthropic and what's happening with Gemini, what's happening with, they can perfectly well do vertical
Sure.
with proprietary data, and they can do that. That's a threat for that portfolio company.
Let me jump in here.
Okay.
Yesterday, a prospective investor talked about protein folding.
Okay.
So say if they can do protein folding, it was Google who did that?
Yeah.
Yeah.
It's a Google.
And could they also do what some of our portfolio companies do? The answer that I gave was no, because in the protein folding, all the data that's available is public. There's no patient-specific data. It's a more general scientific data around the globe captured by the model. And the model computing.
I mean, they can buy 1, 2, 3 me. I know
Yeah,
they went back. They can purchase. They can do that, and they can do it.
Your computing power to solve the problem. When you're talking about the kind of companies that we are investing in, their proprietary data is illegal to be made public because it's
Okay.
a patient specific.
Okay.
So if you have 4 of us sitting here and we all have different chronic diseases, our DNA, our blood work, our prescription medicine history,
Yeah.
those are proprietary data. They're protected by law, by regulation. The only reason a general purpose LLM would have it if they broke into healthcare data,
Right.
or they stole it, right?
Right.
Otherwise, they have no access to our proprietary data. But our companies, they got it legally. We all patient agree to give it to them, and they agree to protect it, and they use the data to help us improve our well-being.
It's harder, right? And other thing is, as you are treating the patients, every patient is different, and you have that data and how certain cures impacted those patients. That knowledge, that information is very, very proprietary, right?
Okay.
As compared to, for example, protein folding, which Al was talking about. It is a combination of neutrons and how the proteins are made, all the components of the protein, right?
Yeah.
Which is a well-known thing, right?
Yeah.
It's just the different combinations of those things fold differently, right? So it's a generic problem. Solving that was a huge deal. It's it's solved by Google AlphaFold. That's the application which they built. It's a tremendous thing what they did, because earlier to find the folding patterns of a particular protein took a long time. You were probably able to do 2 or 3 protein folding solutions per year. And now they have a solution where pretty much most of the protein folding is solved already. So it was a tremendous thing what was done, but it's still open generic data which is available to everybody.
Going back to our model for Quartus, things that we see or we hear buzzwords, agentic, world models. We're seeing multimodal architectures. We're seeing embodied or AI embedded,
Right.
embodied AI, whatever the different terms. What's our take on these? Is this a signal, noise? What's happening in terms of?
No, it's not. Well, it's interesting. Okay. And let me put it this way. So this was the second thing, which is happening with our framework, if you will, which is essentially We had LLMs, which came into the open market, if you want to call it,
Okay.
when ChatGPT was announced back in 2019 or something like that, right? So it was just LLM, but since then, if you really look at it, there has been constant innovation which has been happening around that. One of the things most of the pioneers of people who are actually championing LLMs, transformer-based solution, essentially, they all were firm believer that scale is the name of the game. Bigger and larger LLMs you have, faster, GPUs you can deploy, you can solve, very complex problems, and that's what they did, right? Whenever you do something like that, there comes a time when there is a law of diminishing return which comes into play. Right. That how much more you can pull out of this particular architecture. Okay. And we have pretty much reached there. So once we reach there, the same people who are champions of LLM, many of them, right, very well-known names, they started thinking that that's it. We have reached the end pretty much. The remaining 90% and 10% of the 90%, over 100%. If you want to solve that, it's going to be extremely hard. It's going to take a lot of energy and resources. So they started thinking differently. They said, if we want to go to AGI, this is definitely not the way to get there. Now, LLMs, obviously, they essentially are natural language processing architecture. That's what it is, right? And what they were able to achieve is tremendous. Nobody thought that LLMs will be able to do all the stuff which they are able to do. Okay. Because they were natural language processing. Of course, they can understand language, right? They can process text. They can predict the next word. That's what they are, right? So now, many of the experts in that field have reached that point where they are looking at the next stage. And some of them still believe in the old one. So the people who still believe in the old one, they are building agentic AI and all that stuff, right? But the others are gone to the world model. That's the concept being talked about. They are experimenting with the reinforcement learning, any other models. JAPA, which is came out of Meta, that architecture is being discussed and talked about, which is part of the world model. Because people realize that if we want to go to AGI, we need to start looking at building the models of the world in different areas and field. That's what the world model is, right? We need to look at three-dimensionality of the world which we live in, not just text-based.
And that applied to the vertical that we invest in.
Well,
we have the proprietary data. We have the moat is keeping that intact, but it can very well use the world model as opposed to the LLM that they're using.
It remains to be seen how it can be used.
Okay.
It's quite possible that some applications are fine by using LLM.
Yeah.
Right. LLM is not going anywhere.
Okay.
Right. It's not the end of LLM and beginning of the world model. Both are important.
And combinations, say OpenAI, OpenClaw, that combination having the agentic built in or acquired.
Right. So agentic is a natural progression. You had the plain vanilla LLMs in the beginning. Then you started talking about RAG systems because you wanted to bring a bit more intelligence into that, reduce the hallucination, if you will. So you kind of integrated with your vector databases and you said, this is the RAG system. Then you started building reasoning models along with that, where you reason, you had chain of thought, which you built around it. So a lot of tooling which was built around LLMs to make it more and more intelligent and interesting. Then you said, okay, now I want to be able to do some tasks. So you built the agentic AI. So that is a normal progression. Now, when the world model comes, the agentic AI is still going to be there. It will just start taking advantage of the world model now, right? And it'll become more intelligent. And that's where I believe eventually we may be, quote unquote, may be able to get to AGI, right? Okay. With plain vanilla or no matter what we do with the LLMs, we're not going to be able to get over there because it doesn't. It actually looks at the history and then predicts something very next move. It doesn't really look at the world as an environment in which we live in, where everything is changing. And that's what you need from the AGI perspective. Just like we are here,
Right.
I'm not the only one which is changing or moving.
No.
We have two other people sitting over here, right? We have cameras running over here. So how this whole environment is changing from one stage to next stage cannot be achieved by just text.
That's why they need to hurry up and get us our quantum computers.
So
Sure.
we not digress, but we went deep into what it is, the things that are changing. Taking it back to the LPs, what should they think about when the risks or the AI risks that you're seeing within
Right.
Quartus
So-
Capital?
One thing which is happening because of some of those very smart people who are actually moving to the world model. This time, I like to say this: research is being publicized. Before LLM came in, there was still huge research going on. We didn't reach ChatGPT moment in vacuum. There was a lot of research. We didn't know. Public didn't know, LPs didn't know, nobody knew what is going on, right? Very few people knew about
Right.
that. But now, because very famous people are moving from your LLMs to the world model and beyond, it is being publicized. Everybody knows about it, right?
Right.
So the LPs, which essentially means that although there's a very exciting things which will happen, but there will be a lot of research which will be happening. So where should LP invest in? It's a very tricky if they end up investing in something which is the research level stuff, but it's not going to go anywhere. Remember, 80%, 90% of the research is going to be just experimentation,
Right.
right? So you could end up investing in an experimentation and lose your shirt, and it will go nowhere, right? So they need to be extremely worried and cautious about it. They need to be talking to the people who understand that whole space, who understand the dangers of this research being publicized or public research, which is happening, and talk to the experts and invest in the areas which are protected from that point of view.
In terms of time frame, how do you see this in 5 years? Do you have any? I mean, people say I can't plan 5 years. I just even 3 years. But what's your take on?
Very smart people than me, when you talk to them, some of them say, next year we are going to be able to achieve AGI. Others say, no, never, maybe 5 years, maybe 10 years down the road. Everybody's guessing right now. Nobody really knows what exactly will happen. And whenever, this level of investment is going into the research, you don't know where the breakthrough is actually going to be, right? But few things are very clear. I mean, we know, for example, robotics is coming. There is a constant progression which is happening in the robotics area, right? And then, of course, which is not the AI, but quantum computing is around the corner. So that is happening. And how, if the quantum computers actually become viable to be able to solve beyond some of the basic problems, we know they can solve, for example, security problems, right? But if they can solve other problems as well, the speed of compute which they will provide, how it is going to impact the research which is happening on the AI side. So it's very difficult to predict exactly what
What's Quartus Capital time frame, or what's the time reference that you have? 2 years, 3 years, 5 years?
For what?
For your planning.
Well, we plan, obviously, because it's a fund, and fund spans about 9 years, right?
Okay.
So whenever we are looking at these companies, we want to make sure they survive.
Okay.
There's something I'd like to interject here is there's a difference between the scientists and the engineers. And when you think about it, these guys that are building the new models, they're really the scientists. You can't, like you said, you can't predict when you're going to get the next breakthrough, because many times it happens by accident or happenstance. But when you're in the engineering side, you are now building applications. That's much more predictable. We're investing more on what would be the engineering side. So while we can plan for the potential of the scientific breakthroughs, it may or may not affect our business on the engineering side until 4 or 5 years after.
Right.
Good. Well, thank you so much. I think we have covered the playbook in detail, and we will see you in the next episode.